Unlike in aviation, which is regulated almost solely by authorities specific to aviation, Aviation Spectrum is regulated both by aviation and telecommunications authorities. So in this session, we're going to bring together both sides to discuss spectrum regulations as they exist in the United States and Europe, and also in a broader global context. And I'm pleased to have Mr. Steve Kramer moderate this session. Steve has served as the director of the Air Navigation Bureau at ICAO since April of 2015. He began his career in air traffic operations as a private pilot. Steve previously has held a number of executive and managerial positions at the FAA. And he has over 33 years experience in the air traffic and international aviation organizations. He also served as a member of ICAO's Air Navigation Commission as well. So Steve, thanks for joining us and welcome. I'll turn things over to you.
Okay, thanks, Terry. It's a pleasure to be with you this morning, and I want to thank you and RTCA for the opportunity to join this panel and moderate this discussion. It should be very interesting, and I hope that the audience has a chance to interact with us. You all have the interaction methodologies that have been laid out in the administrative areas, and we'll look forward to the questions that you may have. Let me first briefly go through and introduce our panelists in the order that they're going to be speaking in, and then we'll jump right in. With us, we have Sandra Wright. She's the manager of the United States Federal Aviation Administration Spectrum Planning and International Office. Serving in that role, she brings 20 years of experience as a military, government, electronics and electrical and electronic equipment expert as an electrical engineer, working in radio frequency compatibility testing, radiation hazard, interference resolutions, etc. She leads a team that works on spectrum compatibility and policy for communications, navigation, surveillance systems, including hot topics such as 5G compatibility, unmanned aircraft spectrum standards and policy, and commercial space spectrum considerations. She's currently focused on building strategic partnerships to enable new spectrum opportunities for aviation and champion aviation needs for a national spectrum policy and strategy and a World Radio Conference 2023 outcome that best suits the needs for future aviation spectrum. Following Sandra, Dr. Sunichi Futasumori is joining us from Japan. He holds a PhD from Hokkaido University in Sapporo. He's a senior researcher with the Electronics Navigation and Research Institute, where he joined in 2009. He's been engaged in the research of millimeter wave radar systems and electromagnetic compatibility issues, including radio altimeter interference due to 5G mobile systems. From the UK, Steve Green joins us. Steve chairs the European Conference of Postal and Telecommunications Administration's Electronic Communications Committee Project Team 1, which deals with mobile spectrum issues. This is the leading group in Europe on IMT matters, and is preparing the CEPT positions on the WRC 15 agenda, including items 1.13, 911, 912, and 918. Steve is serving as a principal in the Spectrum Group at Ofcom, the UK regulator for communications in the UK, and he's leading international activities of the Spectrum Technology, Engineering, and Enforcement team. And then finally, we'll be joined by Hete Hokema. He is the chief expert on avionics and electrical systems at the European Union Aviation Safety Agency. He's been in the aviation industry for over 25 years, and his responsibilities include the development of regulations, policies, and standards in the fields of avionics, electrical systems, software, airborne electrical hardware, development assurance, and flight controls, and in the consistent applications thereof. He's a chief expert supporting certification teams and providing advice to EASA management at all levels. He's also still actively involved in the certification of avionics at the aircraft and equipment level. Since he's joined EASA, he's played an active role in the development of policies on comm, nav, and surveillance, as well as specific policies in the different types of aviation. He's also supporting a number of groups at EUROK and RTCA, and is currently the EASA representative in the EUROK TAC and RTCA PMC. So this is a well-rounded panel with a lot of experience, and we'll dive right in and start with Sandra's presentation. Over to you, Sandra.
Thank you, Steve. And what a pleasure to be here with everyone today. I'm really excited for this opportunity to engage the RTCA Summit on topics that are very near and dear to my organization at the U.S. Federal Aviation Administration. The U.S. National Aerospace System relies on regular updates from critical radio frequency-based technology. And our office works to manage and protect those frequencies that they use and ensure that there are policies in place to support innovation for the future of aviation. COVID has definitely brought attention to the importance of connectivity and the benefits that can be gained, often through mobile, broadband, and satellite means. The FAA, though, has acquisition timelines where we often have to deploy and maintain equipment, planning for 30 to 40-year life cycles. And we've seen that it's been outpaced with this exciting pace of technology. While most discuss spectrum and the facts about it being a finite resource that has to be well managed, which I definitely agree to, my comments today are going to focus on the opportunities for innovation that our current spectrum environment has provided us. If you'll go to the next slide. This shows the US spectrum regulatory framework. And here in the US, all of the government users, including the US Federal Aviation, go to an organization called NTIA, where they support our agency mission needs. Industry goes to FCC, and they champion all of the industry needs. We come together at a monthly meeting called the IRAC, where we have regular engagement to discuss current policies, how they're working, as well as future upcoming systems. Next slide. This slide just shows a few of the radio frequency-based equipment that are on board a conventional plane that interacts with the National Airspace System. We are creating policies. When we're creating policies, we look at what mandatory equipment is, and this is a really serious topic. So as new entrants to the spectrum, we look to see how we can protect this equipment and not look to change with a new equipage to aircraft. Next slide, please. With our work within FAA Spectrum, we have definitely a lot of hot topics that have been going on. Recently with 5G, we've had opportunity to realize the importance of engaging with industry, and we look forward to opportunities as new spectrum entrants or requests come in, how to also improve that engagement with industry. We're looking at UAS, MOPS, and policies for different types of UAS. And then advanced air mobility is a huge initiative within the US FAA. We're also looking for ways to make commercial space integration possible throughout the NAS, and what communication, navigation, and surveillance systems are needed in order to make that happen. We look at other agency systems like Link 16, which is a defense system that's used globally. And then we're always looking at system-to-systems approaches. So how can we combine different systems and put them into one technology to reduce the amount of equipment maintenance and combine the technologies available? Part of that we did with ADS-B. And the ADS-B system was the first time that instead of the US FAA purchasing equipment, we purchased a system and allowed that system to be maintained by an external user. And we're seeing the benefits of that. We've noticed that there are opportunities for the very mature infrastructure we have in the United States of the communication backbone, and we're looking at opportunities to leverage that technology as well. So with these hot topics, they provided us opportunities to relook at our existing framework of how we do regulation and see if there are opportunities to change, to improve, and to do additional outreach. Next slide, please. What we've found is as we do outreach to the various communities that we engage in, these strategic partnerships have been key about learning what concerns we have globally. So groups like ICAO, where we attend the Frequency Management Spectrum panel, have been key in understanding what aviation needs are right now and for the future, as well as items like the ITU, the International Telecommunications Union, where we work towards the World Radio Communication 2023 agenda and make sure that we're positioning aviation correctly in the future. I look forward to building additional strategic partnerships, and I welcome your thoughts about other ideas of how we can engage. Thanks, Steve.
Thanks, Andra. Sorry about that. So I want to just reflect that what you've outlined for us is a rapidly changing environment with a wide variety of stakeholders at both the industry, then in the US government, and then internationally at all levels. What a complex soup. So we'll look forward to talking about how we can innovate in that soup here in a few minutes. Sunichi, over to you, sir.
Thank you. Yes, thank you, Steve. And it's honored for me to attend this session. And hello, everyone. My name is Shunichi Tatsumori from Aircraft Navigation Research Institute, ENRI. Our institute is National Research Institute of Japan and working for the developing future ATM CNS system. As a National Research Institute, we are investigating the aircraft radio altimeter and 5G mobile system interference issues. Today, I would like to introduce the situation in Japan as a typical case. Next slide, please. Yes, first of all, I would like to start with the brief summary of RA and 5G interference issues in Japan. In July 2018, Information and Communication Council, Ministry of Internal Affairs and Communications, which is Spectrum Regulator of Japan, published the investigation report to harmonize the aircraft RAs and Japanese 5G mobile system. And in April 2020, four mobile phone companies launched commercial 5G service using the frequency band from the 3.6 gigahertz to 4.1 gigahertz and 4.5 gigahertz to 4.6 gigahertz. We can see the guard band for the RA band is 100 megahertz, which is different from the other countries such as the US and most of the European countries. And in addition, the 5G mobile communication system is operated in both sides of the RA band. However, in response to the RTC report on the interference issues of the RAs and 5G, aviation stakeholders in Japan, such as aircraft operators, JCAB, and ENRI, hold the working group at ATEC, which stands for the Association of Air Transport Engineering and Research, collaborating with the MIC and mobile phone companies since April 2021. We understand that the Japanese spectrum conditions surrounding the RA is something special compared with other countries. Because of this, currently the spectrum sharing conditions of RAs and 5G mobile system in Japan are being validated by the ATEC working group using the newly obtained experimental data and RTC local technical guidance document. Next slide, please. This slide shows the current activities of ENRI. We participate the ATEC working group for discussing the RA and 5G interference issues. This year, we conducted 2 measurement campaigns at the ATEC working group, joint and collaboration with the All Nippon Airways, All Nippon Helicopter, Japan Airlines, and JCAB Flight Inspection Center, Japan Coast Guard, and Nakanihon Air. Figure on the left-hand side is the RA interference characteristic evaluations with Japanese 5G conditions, especially with the narrow guard band. We investigated the 20 RAs in total, in 12 for the large fixed-wing aircraft and 8 for the medium and small wing aircraft and helicopters. And figure on the right-hand side is the RA interference path loss IPL measurement, which evaluate the effects of the 5G mobile handset inside the cabin. We carried out the IPL measurement using several types of aircraft, including the fixed wing aircraft and helicopter. RA5G issue is one of the ENRI Spectrum studies, but we also participated in several RTCA and EUROCAE working group shown here. And next slide, please. Going back to the issues of RA and 5G, I would like to discuss 5G frequency allocation and current mitigations. This figure shows the sub-6 5G frequency allocation in Japan. Public 5G network is operated in 3.7 GHz band, which is 3.6 to the 4.1 GHz, and 4.5 GHz band, which is 4.5 to 4.6 GHz. In addition, the private or industrial 5G network is assigned for the 4.6 to the 4.9 GHz. Maximum ERP for the public 5G network is the 60.8 dBm per megahertz. As a mitigation measures, limitations of the installation locations are applied to the adjacent band. Figure on the bottom show the 5G restriction area around the airport and heliports. Rectangle area are in the red, shown in red color from the line edge, which length is 1,000 meters, and surrounding area of the rectangle area, which is the 200 meter restriction area. No 5G base station is allowed in this area. And in addition, the restriction area of the heliport is inside the red circle, which diameter is 50 meter or 20 meter, depends on the transmitting power of base station. Currently, this restriction is only applied for the base station with the 100 megahertz guard band. There's no limitations for the base station with more than 200 megahertz guard band. Next slide, please. This picture shows the satellite view of the central Tokyo. Central business district is located on the left-hand side. We can see that Tokyo International Airport, Haneda Airport on the right-hand side. In addition, the Tokyo Heliport, which is one of the largest heliports in Japan, is located on the top of the picture. And orange area is the restriction area of the 5G mobile base stations with 100 megahertz guard band. The sub-6 5G mobile base stations are still being installed and not spread across this area, especially for the base station operating 100 megahertz lower than RA band. However, we understand the frequency condition in Japan are getting more severe for radio altimeters in near future. So we will plan to carefully investigate interference. Finally, I would like to mention the importance of the international standards. The standard development carrying out by RTCA and EUROCAE is very important for us because the safety of avionics cannot be accurately assessed by only one national spectrum regulator. We look forward to the future publication of the guidance document on the radio altimeters. Thank you very much.
You know, I haven't, it's clear I've been on leave for the last week. I've forgotten how to use Zoom. I apologize. So Dr. Futatsumari, thank you very much for your very clear and detailed briefing. I'm looking forward to getting into some of those details and the questions. Next up, we have Steve Green from Ofcom. Steve, floor is yours.
Thank you, and good morning to everyone. Good afternoon from the UK. So I'm chair of ECCPT1, which is a group within CEPT, and I thought as an introduction I should explain what CEPT is. It's an organisation of European national regulators in spectrum, and there are 46 member countries there, and you could see there, and obviously 46 countries in what is a fairly small geographic area means a lot of international borders. So there's a definite motivation for regulators to get together, come up with common policies as far as possible, and harmonize technical regulations, because the other thing is for the market size, individual countries are not a sufficiently large market for equipment, especially for mass market equipment. They do create quite a significant size economic bloc, and so where we can harmonize technical conditions for spectrum, that's a benefit to those member countries. So within CEPT, we develop a number of regulatory deliverables. We have ECC decisions, which are in areas of significant harmonization. Now, although it's called decision, it is not mandatory or binding on the members, but the signal got together and created this document that they call a decision, that it indicates there is a significant will to implement that. And in fact, we have an online, there's a website maintained by CEPT, which indicates which countries have implemented the decision, and the intention is as many as possible should do so. We also have recommendations which are more about indicating national options and frameworks that can be put in place, and we have reports which are effectively technical studies, and they're usually done in support of the work towards a decision. Now, we don't develop specifications or standards in CEPT. There is a separate organisation called the European Telecommunication Standards Institute, which does telecom standards. But for CEPT, our focus is really on the spectrum regulation. Like I say, it's what national regulators would normally do, and we aim to get together and try and come up with common policies there. So next slide, please. So within CEPT, we have the Electronic Communications Committees, as distinct from the postal side, and in the ECC, we have a number of project teams dealing with different subjects. So we have project teams dealing with satellite issues, for example, fixed links, short-range devices, and so on. And the group that I'm chairing is PT1, which is focused on mobile network issues. So 3G, 4G, 5G, and at some point we'll be looking at 6G. And we do is a combination of the harmonization measures for spectrum that has been identified internationally for mobile. So, for example, we recently worked on the 26 gigahertz and 42 gigahertz that came out of WRC 15, and we have also been recently looking at the impact of active antenna systems and what that means for existing regulations. And in fact, we've been updating some of our regulations so that they reflect the option to use active antenna systems. And we also prepare for WRCs. And for this conference, we're looking at, in fact, we're looking at 1.2, 1.3 and 1.4. 1.2 is the one that deals with mid-band, potential additional mid-band spectrum, including the upper 6 gigahertz. 1.3 looks at 3.6 to 3.8 gigahertz across the whole of Region 1, which is Europe, Middle East, and Africa. And then 1.4 is looking at for high altitude based stations, which is located on, for example, located on airships at very high altitude to provide. One of the key things that we're looking at right now, and we've been asked to look at by our parent group, is the coexistence with radio altimeters. So you can see the diagram at the bottom. We've got a big rollout across Europe of 5G in 3400 to 3800. So it's a slightly different boundary to the one in the US, and then there's 4200 to 4400. So we're trying to look at the issues of coexistence between those two, and to do some analysis on that. We've also recently been asked by the European Commission to look at a possible harmonization measure for low and medium power local access. So this would be different from the mobile network type deployment that you see for 5G in 3400 to 3800. This would be more of a kind of an industry, or what they tend to call verticals deployment. So it would be private networks around, say, a business park or for an individual. And so it would be, instead of a national rollout, it would be located in specific geographical places. And that's why it's a low and medium power approach. With high power, you would not get the density of deployments, so you'd have to have huge separation distances between different users of that. So keeping it low and medium power keeps it appropriate to the sort of coverage that we're talking about, but also means you have not such a large separation distance. And hopefully that will be a good neighbor to radio altimeters because of being at a lower power than the 5G type networks that you get lower down in the spectrum. So we've been asked to look at that, and specifically including potential coexistence with radio altimeters. So that's something that's kind of just coming on stream. So in the UK, in fact, we've already got some networks running on that. And this is looking at a potential harmonization across Europe. So next slide, please. And for our work on the coexistence, we have 3 meetings per year of ECC PT1. Each one is a week-long meeting, but we have lots of subjects, as you can imagine, to discuss in there. So we have to schedule particular slots for each subject. So those meetings are operating as hybrid meetings, which means we're meeting in a physical location. Our next meeting is in January in Edinburgh, in fact, but we also have online participation. So and request to speak and take part in the meeting that way. We also have, between those main meetings, we have what we call correspondence groups on specific subjects. One of those is focused on the radio altimeters topic, and we've been scheduling those for what's afternoon in the European time zone, so that it facilitates participation by those in the US and Canada. And participation in our meetings, as I indicated on the first slide, it's a forum for national spectrum regulators, but our rules of and our working methods also allow participation by industry. So we have members of the mobile industry, and we've also been having members from the aviation industry participating in the meetings. So we aim to facilitate that discussion by the relevant, and do it as much face-to-face as possible and directly, rather than having to go through a national administration. So what have we done so far? Well, we've been gathering the technical parameters for the different systems, so all the 5G parameters. We're also still just low and medium power parameters. So for example, what do we mean by low and medium power? What exact power limits we're talking about and what sort of deployment scenarios there. One of the things that has slightly delayed our progress is that we were waiting on critical coexistence scenarios for radio altimeters. Obviously, a key thing if you're going to do the analysis is which sort of geometries do you need to look at for the analysis. And we in the autumn this year we received a copy of the guidance document on radio altimeter RF interference rejection and tolerance, which I think came out of our RTCA. And so that was sent to us during their open consultation and FRAC period. So we were invited obviously to put in comments there. So we won't be putting in, or we haven't put in a PT1 comment for to put those comments in. Of course, that we're aware that that closed, I think, on the 2nd of December. So, but that's really useful for us to see what the latest thinking is on radio altimeter performance, and also to have that information on the critical scenarios. So that concludes my presentation. Thank you.
Thanks, Steve. And now, Ete, it's over to you for the closing presentation before we go into the questions.
Thank you, Steve. When Steve was presenting CEPT, I realized I should probably have presented the role of EASA in Europe, and how we share responsibilities with our member states, but I haven't, so I apologize for that. Maybe I should do better next time. I should also apologize for the fact that you may see some rather provocative statements on these two slides that I'm going to present to you, and that's intentionally done so. The reason for that is that I believe that if we as the aviation industry do not ask ourselves those questions, the IMT industry, regulators like Steve will ask those questions from us. So we need to be prepared to answer those. That's not to say that I always agree with what we put here, but it's certainly a discussion that I think we should have as an aviation industry, as aviation regulators, to make sure that we prepare ourselves for the future in the best possible way. Now, historically, aviation has been applying a rather conventional approach to spectrum, and the question really is, should we do something different? I think, what I've come to realize, in recent years, is spectrum is a really scarce resource, and we need to learn how to better value the spectrum that we use. Just to look at that radio altimeter spectrum that everyone's talking about these days, that's worth billions. And I'm not saying, I'm not trying to argue that aviation should pay for its use, but we should know how to value that. It is a very scarce resource. It's precious. And we need to use it in the best way that we can. We need to manage it in the best way that we can. I've also come to realize that the 5G case is not unique. It's not the first, and it will probably not be the last case of potential interference. So we need to, continuously pay attention to spectrum. That is an absolute requirement. And coming back to to the case that we've seen Ligado, LightSquare, and GNSS in the US. We've seen a discussion with PMSE and DME in the UK. We've had FM immunity in the past. So that just shows that we shouldn't think that when we solve this 5G case, that's it, and we can all sit back and relax. We need to stay vigilant. And so I'm really wondering if a new approach would be needed. One thing's for sure, we need to learn to manage our spectrum more efficiently. And when I say that, I don't mean the way that we manage spectrum in the way of, where do we put it, but we need to make sure that our systems are designed such that we are robust and that we're good neighbors to to the other spectrum users. So when I talk about spectrum efficiency, it's really applying the latest technology to make sure that we use that spectrum in the best way that we can. We also need to be quicker to adapt. We have, in a way, seen part of that in the 5G case, where I think the aviation industry has responded much quicker than we've ever seen in the future. But it's really resource intensive. It takes a lot of resources, and I'm not sure that is sustainable. But we need to think about better ways to adapt more quickly to changes in spectrum. And here we go, probably for the most provocative statement on this slide. Should we perhaps be a bit less dogmatic on what we view as protection? Now, don't get me wrong here. We're not ever going to compromise on safety, never. But we may be able to look at new technologies to do, more in terms of sharing, more in terms of better protecting ourselves, but not necessarily in the way that we protect our spectrum today with guard bands, etc. So next slide, please. And I think that this new approach also implies reaching out to our neighbors. I was watching one of the earlier sessions, and Dee Rijmold, I think, had the exact same message. We need to foster direct communications with other industries, be it the broadcasting industry, the mobile industry, spectrum regulators. It is important that we do that, and I'm very glad that some of the IMT members in the CEPT actually reached out to me, and I had some very good discussions. I learned an awful lot about the way that they operate their systems, and it's not that different. The challenges that they face are not that different from some of the challenges that we face in aviation. So we have a lot of commonality. We're all engineers in the end, and so we can have that good level of communications between the industries. And lastly, I think my message is that spectrum should become part of our DNA. And I strongly believe, this is not to challenge any of the work that ICAO, FSMP, or the ITU World Radio Conference do. Don't get me wrong. But I think if spectrum should become part of our DNA, we should discuss it at more levels than just there. It shouldn't go, all the way up and then down on the other side. We should have those discussions, at many more levels. And here, I think there's a key role for RTCA and for EUROCAE. EUROCAE Working Group 124 and RTCA SC 242, I think, have gathered the best experts that we have in our aviation industry on spectrum, and I think that we should be very careful that we maintain that. So again, going back to, once we solve the 5G case, that's not going to be the end of the story. We need to make sure that we maintain our expertise, that we continue to support these working groups. And these working groups may actually help us to have those discussions at all levels, including providing support to the FSMP, but also, like Steve was discussing already or alluding to, many of the members of that working group are actually supporting the discussions in the CEPT as well. Again, I really appreciate the work that they do, and I thank them very much for that. And I hope that, in the end, spectrum will indeed become part of our DNA whenever we start thinking about new systems, but also updates to current CNS infrastructure. Thank you very much.
Thank you, Hedy. Listening to you and to Steve, I had to chuckle when I said that Sandra's situation was complex, because honestly, I always forget that the European construct for governance makes almost any other region look reasonably benign. So I'm kind of laughing, but I'm kind of joking about it. But in reality, it is a really complex challenge. So we have two core questions that we were going to address. One is, what are the recent developments inspiring innovation in our processes, regulatory processes? And what can spectrum stakeholders expect in the future? And what I was struck by was the level of detail that Shunichi was able to present to us about the specific issue of how 5G has been managed in the Tokyo area with the charts that he provided. A layperson can go look at that and go, okay, I see what I would want to do. My question is, how does that get infiltrated through the community to where it becomes part of a data set that a policy regulator is able to take action on? So I'm interested in a little bit of a discussion around how you take all the different pieces of information and then discover you've got a problem, go to do the research, and then make sure that that research is peer reviewed and checked and available for the policy work. Shunichi, because you gave us that presentation, I'd like to ask you if you want to kick off.
Yes, in our situation, a little bit complicated because the launch of the 5G service is much earlier than other nations. It's almost two years earlier compared with the US. So we carried out something like a fundamental interference analysis based on the previous document, such as ITR M2059 or something like that. But afterwards, the RTC and EUROCAE carried out the a huge measurement campaign, and based on that, they carried out some standards. They carried out specify some the interference conditions. But before the RTC and EUROCAE published the document, we already determined the harmonization conditions. That is a very difficult condition for us because the at that time of the in our countries determine the mitigation measures set up, but currently our mitigation is, we think it's not enough to protect the array, so that in the first stage we have to summarize the every information we need for the interference analysis, so that we need to collaborate in a huge community, in a large community in future, not for the 5G, but for the future communication systems.
Okay, thank you. And we've had an audience question, which is asking, what are the 5G base station power, the EIRP power that operates close to the airports in Japan? Do you know what those are with the 200 megahertz and 100 megahertz guard bands to the 4.2 to 4.4 gigahertz band?
Just one, please.
Maybe we can come back to that if you want to think about it.
Yeah.
So I'd like to ask the others if they'd like to chime in on what their views might be on this question. Sandra?
Sure, thanks, Steve. And I really appreciate the comments from Shunichi and Hedy talking about RTCA Special Committee 242 that's joint with EUROCAE Working Group 124. And when I look at innovation for the future, I really like what this group is focused on. So I want to just take a quick second for folks that aren't familiar with. This is an opportunity to ensure that the radio frequency characteristics for aviation systems are specified in kind of a consistent and complete manner. And they are developing guidance for the RF parameters for the transmitters and the receivers that will include information like performance requirements, out-of-band emissions, spectral efficiencies. And what's envisioned is that this information will be put together in a reference document for regulators, but also given to radio system designers. And so I see that ICAO, ITU, as well as other organizations will use this information to help inform them for future studies where they're proposing new uses of the spectrum, and they can use this information about the characteristics of aeronautical systems to determine if compatibility is possible and under what criteria. So I think that's a huge development in our community, and I really encourage participation in that effort. The other item that I want to talk about is a discussion on receiver performance requirements. We've been having this discussion in the US, spurred by comments from the FCC of opportunities to, industry would like to come closer to aviation spectrum, but how do they do that without certain receiver specifications, as well, not just aviation, other spectrum bands. And so we're having the discussion of how do we create receiver performance requirements, out of band rejection. And so I think that that's another interesting topic that I think that can advance our community, the spectrum scenario globally, but definitely help improve in the aviation sector.
Okay, thank you, Sandra. And Hete, I'm going to ask you the question. I guess the challenge that I'm hearing from a safety regulator perspective is, how can we define new methods to truly test the edge of performance that will satisfy a safety regulator in a manner that can be validated for global adoption? Because that ultimately is required kind of on the front end before we can go make a case for an amendment to spectrum utilization across the board that might accommodate a new industry, or make the case even for aviation to move into a different place in spectrum if that was required by a future application.
Yeah, that's indeed a very good question. I don't know that I have the immediate answer. I think what I would refer back to is, as Sandra did, that Special Committee 242 Working Group 124. I think that should become our pool of expertise, of aviation expertise in this field. So when a new entrant, a new use case arrives, I think that we may have to turn to them and make sure that they develop the methods to assure us as safety regulators that the use of that spectrum for that particular purpose is safe, and that we can build standards for that use case that we can then adopt in our regulatory system and be assured that safety is guaranteed. I'd also like to perhaps come back to your organization, Steve. I think what we also need to do is, we have a lot of expertise in the US and Canada and Europe, and a lot of those people are on the call right now, if they're not in Paris, working on the radial altimeters as we speak. But there is also a huge community out there that may not have that same expertise. And I think reaching out to them, giving them guidance as to how they should implement, these new spectrum criteria, spectrum related criteria, receiver, standards. I think that we should have a discussion in ICAO as well as to how we can do that better, so that they also benefit from what we're doing in these two working groups, and with all the experience that we gain in discussions with CEPT and other organizations.
Okay, thank you. That's inspiring for me to know that there's a place for ICAO in the process that could actually be amplified and strengthened. But I think it needs to also, as you've said, take advantage of the technical specifications and the working group knowledge that's available in the RTCA and EUROCAE committees. Steve, for you, the question I want to just sum up with is, what can we all do as an aviation community to strengthen our hand to make sure that when we say we have an issue, when we say there's a problem, when we say we've done research, we've got the credibility that we need to have when we come to the global marketplace for spectrum?
Yeah, I think it's partly about having that conversation early and having that engagement with the with the regulators. So whether it's the national regulators like you have in the US and Canada, or whether it's individual national regulators in Europe or through the CEPT process, it can sometimes seem like many organizations a bit cumbersome to outsiders, but we try and be as open as we can. So, for example, we don't have password protection on our documents. They're up there on the website so that anyone can look at, and we try and be responsive as well. So when people started raising this issue, we acted to create a specific work. We had to reach out to the aviation industry, and there was we didn't immediately have the ideal contacts, so there was a bit of a time lag between starting things off and actually getting that engagement. But I think we're now at a good place in terms of getting that engagement. It is about talking to each other, I think, ultimately, and the more we do that, and the more we maintain those contacts. And we recently, EUROK, I think it was, or has organised a letter of understanding with ECC. So this is a kind of effectively an agreement to work cooperatively to keep each other informed. And I think these sort of partnerships will go a long way to making sure that we can spot things as they're on the horizon. Thank you.
Thank you, Steve. That's a great example. And for the engineers in the room, Dr. Udasamari has told us that the max EIRP is 60.8 dBm megahertz by the regulation, and 55 is typical power. So nobody is pushing the limits at this point. It's not dependent. There isn't a restriction beyond that that's impacting the installations on the ground right now. But you know what? I think that there's so much more to talk about. I'm so thankful that RTCA has set up this opportunity for us to have this engagement between the aviation spectrum community and the rest of the spectrum space. And I want to thank all of our speakers today for their engagement in this particular panel. And Terry, I'll pass it back over to you with the thanks from all of us, and to all of the presenters. Thank you for all the work you did to prepare us for this.